Okay, Team Impact, we are moving on to ratio application today. Tomorrow, which would be Wednesday, we're going to have a quiz over lessons 1 through 5, and there will be some decimal problems on there on a supplemental sheet. So, so let's get after it today, all right? We warmed up to our other packet, so it was a pretty good deal. That's also in the that's not in the folder, all right? So you missed that warm-up if you were out. All right. As you apply ratios to solve real-world issues or situations, consider asking yourself the following questions to guide yourself thinking and determining the reasonableness of your solutions. What is being compared? Right? So when we look at two things, we need to say, hey, are we comparing apples to oranges? All right, shirts to coats, and so on. What information am I given? All right, so when I look at it, I need to read the question multiple times. And then does your solution make sense in the context of the problem? All right, and we always should ask, does my answer make sense? Is it reasonable, right, for me to think that? Okay. Number one, I don't know if this has helped. This thing jumps around that light. Jenna and Becca are both selling cookies door to door. Jenna sold 3 boxes of cookies, or excuse me, Jenna sold 4 boxes of cookies for every 3 boxes of cookies Becca sold. Combined, they sold a total of 35 boxes of cookies. How many boxes did each girl sell? Okay, so what I know, Jenna, all right, I know that Jenna sold 4. Jenna, all right, had 4. And Becca, I like that name, Becca, sold 3. All right. So, all right, let's set it up here. All right, and let's set up a proportion of what we have. All right. So here's the deal. If Becca sold 3 and Jenna sold 4, all right, that's a total of 7. All right. We don't want 7, we want a total of 35. So how do I scale it up? Let me pull that up for you a little bit. So 7 times 5 is 35. 4 times 5 is 20. All right. And 3 times 5 is 15. All right. So when I scale it up to a total of 35 boxes, the solution is 15 equals Becca, and 20 equals Jenna. 20 equals Jenna, right? All right, that was a pretty easy problem. We've been doing that. Let's go to number 2. Latrina is planning to serve hors d'oeuvres at her wedding. She plans on offering 8 hors d'oeuvres for every 3 people. But there's 240 RSVPs to the wedding. How many hors d'oeuvres will she serve? Let's go. I know right now we need 240. All right, hors d'oeuvres, and I'm not sure really. Let's just go RSVP. I know we want a ratio of what? 8 hors d'oeuvres to every 3 people. Okay? Let's set it up. So if I have 8 hors d'oeuvres to every 3 people, all right, that equals 11. All right? I don't want to feed 11. I want to feed 240 people. I want to feed 240 people. So how do I get from there to there is the question, right? Just the same type of problem. So I'm going to take my calculator and I'm going to take 240 and divide it by 11. And I get this crazy number here, right? I get a crazy number here. So, well, wait a second. I think I made a mistake here, all right? All right? Something's not clicking. So when I look at this problem, I'm going to go back and reread it. I've missed something, and that's okay. All right? She plans on offering 8 hors d'oeuvres for every 3 people. If she has 240 people, we don't want to set it up this way. We want to set it up 240 hors d'oeuvres and put X on the bottom. You see, we're going to have a total of 240 hors d'oeuvres. So when I saw I made this big decimal, something clicked and said, hey, there's an issue here. All right, a couple different ways to solve this problem. Okay, so let's get into this thing. We can take 240 and divide it by 8, and we get 30. So that means 8 times 30 is that, and what's 3 times 30? Well, that equals 90 people, right? That's 90, right? All right. Or we could have cross multiplied and divided it by 8. All right, let's move on to the next one. Number 3. Number 3. Okay. The ratio of accessible parking spots to general parking spot is 2 to 75, right? 2 accessible, 75 general, right? If a parking lot designed to hold 385 people, right? Then how many more general spots and accessible spots will there need to be? Okay. So, let's take a peek at this thing here and let's go to work. All right? I have 2 accessible to 75 general, okay? All right. Okay, so what we're going to do is set this up, all right? When we set it up like this, and I'll move that up, if I have 2 accessible for 75 general, I have a total of 77. I don't want 77, I want 385. So how do I get from there to there? And then I can proportionally scale this up. Well, 77 times 5 is that. So I'm going to scale both of these up by a factor of 5. Well, 2 times 5 is 10, all right, 10 handicapped accessibles. And 375 times 5 is, all right, sorry, is 375. So, what are we looking for? 375 general parking spots. All right, let's move on. Rolling right along here to number 4. Joel and Rhonda were comparing their classroom economy bank accounts. The sum of their bank accounts was $160. So Joel plus Rhonda, their sum is $160. The ratio of Joel's account to Rhonda's account was 4 to 1. Okay, so here's what we know: 4 for Joel, 1 for Rhonda. Right? How much money does each student have in their account? All right, so let's take a peek at this thing and get after it. All right, first thing I'm going to do is take these two and add them together, and I have a total amount of $5 in the account. We don't want 5 total. We want a total of $160. So to get from 5 to 160, all right, I'm going to take my calculator and simply just take 160 and divide it by 5, and we get 32. So I'm going to scale this thing up by a factor of 32. All right, 1 times 32 is 32, and 4 times 32 is 128, right? And that's how we got that. So our solution is Joel has $128, and Rhonda has $32. So once you get into the mojo of this thing, it flows nicely, right? All right, let's take a peek at this last question and go. A food distributor ships 8 cases of regular soda for every 3 cases of diet. 8 to 3. 8 to 3. Mrs. Lockett asked students to find a number that could represent the number of cases of diet soda the food distributor could ship. Which students complete the task correctly? So essentially, we're going to scale these up, right? All right, so what we're going to do is scale it up. all right, and we start with 8 to 3, all right? So they ask us cases of diet food distributor could ship. All right, so let's see here. All right, could that work for Barry? Excuse me, I've got the hiccups here. All right, so I have 8 regular, and this is diet, right? So could we scale this up? Could Barry be 1? Well, 3 times 9 is 27, yep. And over here, 8 times 9 is 72. So 72 could work for 1. Why? Because it could scale up by a factor of 9, and that is our diet soda. So essentially, what we're looking for, without doing a bunch of work, is just a multiple of 3. That's not 1. Nothing times 3 gives us 20. That's not 1. 3 times 5 is 15, not 16. That's certainly not 1. But let's look at Jordan. Will 3 go into 36? And sure, because remember the sum of the digits, 3 plus 6 is 9. 3 goes into that, so Jordan could be 1, and 5 plus 1 is 6, and 3 will go into that. So your 3 answers there are Coleman, Jordan, and Barry, because essentially what they are multiples of 3. You could factor it up, the diet up, and you would end up with one of these numbers, okay? Okay, so homework tonight is word problems, all right? So make sure you get it done. We do have a quiz tomorrow. Have a great day.